Okay, so let's just start today by having a look at how we go about evaluating a scheme expression in Impromptu. So we'll just start with a very simple little expression here, and we just go up to a vowel, click on a vowel, and we get the result 6. So basically we can click a vowel anywhere inside the expression. If we make the expression a little more complex, we can press a vowel inside either our outer or our inner expression. So inside the inner it gives us 6, and inside the outer it gives us 12. There's a shortcut for a vowel, which is Apple E, so again 6 and 12. There's also another shortcut, which is control space, which will always evaluate to the outer expression. So it gives us 12 in that instance, and it gives us 12 in that instance as well. You can also use control space immediately preceding or immediately following the expressions. You'll also see as you move through that the expression that we're currently inside is highlighted, so that just helps you find your way around a little easier. Okay, so let's just start. Impromptu is an audio unit host, so we're just going to start today by loading up an audio unit. You'll notice in Impromptu that when the message bar is not returning a result, it actually provides you with the current function signature that you're inside. So here we've got AU create node and 3 arguments, type, subtype, and menu for manufacturer. So we're just going to use AUMU as the type, which is AUMU is the musical instruments, which is the main type of all sort of synthesizers, for example, samplers, etc. on your machine. There are also AUFX for effects, AUGN for generators, etc. There's a whole host. SMD2 is the label of the actual audio we want. In this instance it's Zebra2 and the manufacturer's code. If I evaluate that, we've now loaded up our Zebra audio unit. If I print the audio unit graph now, so we just go AU print graph and evaluate, you'll see down here that we have 2 nodes running. We have node number 2, which is the node we just created, so AUMU SMD2 UHFX, but you'll also notice that there's one node already created here, AUOU AHAL Apple, which is actually the default output device which Impromptu instantiates for you on startup. So what we want to do here is we want to connect node 2 to node 1 so that we can create a sound, and we can do that by using AU connect node. We connect the Zebra's first output bus to the default output node's first input bus. Input and output buses both start from 0. We can evaluate that now, and if we print the graph, we see that there's one event to be updated here. It says connect source 2 bus 0 to destination 1 bus 0, which is, if we look at this, exactly what we want. So source 2 to destination 1. To actually move that from events to be updated to updated, what we need to do is call AU update graph. Now when we call print graph, you'll see that, let's just scroll down, there is one connection here. So we no longer have events to be updated, we actually have a connection. Node 2 is connected to node 1. So we should now be able to create a sound. Let's just go play note now, Zebra 6080 10,000. You'll see down here the signature for play note. And so we have time in samples, so the time that we want this sound to happen, and here we're just saying we want it to happen now. The instrument, the pitch is a MIDI pitch number, velocity is a MIDI velocity number or volume number, and 10,000 is a duration in samples. So here we go. Okay, you'll hear that as soon as I evaluate the expression, it plays immediately because we're using now. So in fact, if we make this nice and short, you should actually hear me play a little rhythm. Okay, so just before we move on, I'm actually going to show you how you can view the audio units on your system, which we can do by using AUMU, which will print out the musical instruments. So here we go. If we scroll down here, we'll see some of the audio unit musical instruments on my machine. So the Zebra 2, for example, is AUMU SMD2 UHFX. For example, we could, rather than using AUMU, we could print out the effects audio units. AU net sends, here are some of Apple's, etc. Delay is AUFX DLY Apple. Okay, so back to our play note. Let's just stick our play node inside a function which we create. Let's just call it f. It's going to be a function that takes no arguments for the moment. We're just going to evaluate f, and now when we call f, you'll hear it's basically working exactly the same as before. I'll just make that a little longer. But what we could do is, now that we've got a function, we can, for example, let's play multiple notes. And let's say 60, 64, 67, and evaluate. So we're now able to play simple little chords there. Let's just make this randomly choose from 63 and 64, so we get the major and the minor. Okay. Now, one of the things you can do in Impromptu, which is nice and a little different, this is basically one of the main things you're going to use all the time, is the ability to call a function at a particular point in time. So what we're going to do here is we're saying we want to call back in now plus 100,000 samples. We want to call an anonymous function, which we're just going to call lambda, that takes no arguments, and it's going to play a note. Now on the zebra, it's going to play 96. Actually, let's make it random. We'll make it choose a random note between 80 and 100, and velocity 80, 10,000. And now when you hear me hit the space bar, or val, you should hear the sound happen just after 2 seconds at time. Let me do that again. Okay. So, the thing we can do with that that's quite nice is we can actually use it inside a recursive loop. So what we're going to do is we're actually going to say I want to call back in 100,000 samples from now back to f. So we're actually going to call ourselves back in 100,000 samples. So let's just try that. Now when I set f off, it should recursively call itself just over every 2 seconds. Okay. Now, while that's going, we can actually just go and change the code in it directly. So let's just drop that down an octave. So you'll hear after it's evaluated, the next time it gets called, it calls with the new value. That becomes a bit more obvious if we speed it up. So let's just speed this up. I'm just going to make this really short again. Now in a second it should start calling itself every 10,000 starting from now. I'm just going to shorten these values as well. Okay, and you'll hear that we can make changes to this while we're going along. So, for example, I could push this up an octave by going plus 12 and back down, or we can make it 24. Okay. Now we can easily stop the function by re-evaluating f to be the function that does nothing. So in other words, we could remove the callback from the function. We can do that quite simply by closing it off. And there we go. Because once we define f as nothing or null, next time it gets called, there's no callback, there's nothing to do, so it just stops. Now, these nows that we've been using are great because they give us a time right now, but there is a chance that, for example, between each of these individual calls now might change. It's unlikely in such a simple function because Impromptu is moving so quickly. This gets evaluated so fast. But still, it's a good idea to get in the habit of using a time argument, which we can be guaranteed is going to be the same throughout the duration of the function. As soon as we do that, though, we've now got an argument to our function f. So over here, we now need to, at the end of our callback, also pass that new function. But that's nice because it gives us a chance to increment the value between each cycle round. Effectively, what this lets you do is create a memory for the function so that we can actually have arguments changed over a temporal period. So here we go. Let's re-evaluate this. Now we have to pass in now. We have to pass in a start time to f, so we're going to use now. So we should now hear it going the same as before. stop that again. I'm just going to clear this up. Okay, now I want to change that sound. So what we're going to do is I'm just going to open the audio units view so we can change the sound. So let me just create a little bit of space here, shrink that a little. Move this in here. Okay, it's still a bit too big. Okay, so what I'm going to do is I'm just going to move over to presets. Let's just choose a keyboard sound of some kind. Okay, pop that over there for a sec, and let's play that again. Oops, evaluate F again, and I'm just going to make that a little softer. Let's just turn all these right down. Okay, now as well as playing notes, we can of course send any kind of MIDI data we like to the audio unit. So what I'm going to do is I'm going to set a control change. So we're going to pass the time, the instrument, the event is going to be a MIDI control change, channel 0. The control change number we're going to use is, let's just choose 91, and let's choose a random value between 1 and 127. And if we pop over here, what we're going to do is choose, let's just choose the cutoff here. So what I can do is right click, choose MIDI learn, and now when I evaluate my function here, it should start sending these control change 91s, which should update this cutoff randomly. So here we go. Okay, so each time around our function it's calling a random number, which is randomly setting our cutoff. Rather than choosing a random number though, let's be a little more deliberate and actually use an oscillator to change that value up and down. So time. Okay, so that's very slowly changing. You can see that slowly changing. So I'm just going to speed that up a little. Okay, that's moving quite quickly now. Stop that for a sec. Okay, what I'm going to do now is I'm also going to add some graphics. So let me just pull this out of the road for a sec. And just create a graphics canvas, which will make 640 by 480. And I'll just drag this up here. I'm just going to clear the canvas and it's going to clear it to black. Oops, sorry, need to pass the canvas in, clear the canvas to black. And now what I'm going to do is I'm going to set up a little graphics function, which again is going to take time. It's going to take some other arguments, but we'll get to them in a sec. What we're going to do is we're going to draw a path, which is a vector path. We're going to draw it at time. We're going to draw it to the canvas. We need a color for our line, so I'm just going to add a color argument here. Draw path, time, canvas. We also need a path, so we're going to add a path to our function. And we don't want a fill color, so we give it the empty color list. And then we're going to, let's just scale the path by a factor. So we're going to scale the path. We want to scale it up by 25%, both X and Y. And we're going to do a center scale. Don't worry about that too much for the moment. Actually, I should add, just before we do that, that if you need help on anything at any stage, so let's just type help scale path in here and evaluate. If we have a look down in our log view, you'll see that it's actually printed out help on the scale path. So for example, we can have a look at that argument, which is type, and it can be one of matrix scale, bound scale, or center scale. Okay, so we've chosen center scale, and then we're going to do our callback, and we're going to call back to time in 1000 samples. and we need to call back to the function gfx, and we're going to pass time and path and color as our arguments, and we're basically done there, except for one thing. I only want to do a certain number of these before we stop. So I'm also going to pass around a num, and we're going to say if num is less than 10, then call back, otherwise just drop out of the function and stop. So what we also need to do though is now every time round we want to increment num by 1. So I'm just going to evaluate gfx. Now I'm not going to call gfx in the same way and just leave it running forever like we did with our audio loop. I'm actually going to call gfx from our audio loop so that this loop gets called every time round this loop, or every time we get a new chord played. So effectively what we're going to have is 2 loops operating simultaneously. In fact, if this loop animates slower than this loop, we may end up with many of these running at the same time. Actually, let's just do that to start with so you can see that obviously. So I'm just going to slow these down a little. This just means that our animation is going to happen a little slower. We'll speed it up again in a minute. And let's also slow these down just a little bit too. Okay, so we've evaluated gfx, we've evaluated f, we should now be able to play it, and every time we get a chord you should also see the start of an animation of a square. So here we go. So there's our function f is now looping again. All we need to do is add gfx as a call to the start. We're going to pass time. We need to create a path, so we're just going to create a simple square. We're going to choose a random position on the screen between 640 and 480. The size of the square, let's just make it 10. We need a colour. We're just going to create a random colour. Let's make it random red, green, blue and 100% alpha, and we need to start our num at 0, remembering that num is going to increment, and we're going to increment up to 10. So now when I evaluate here, you should see the squares start drawing in the graphic window. So what's happening is that every time that one of our notes plays now, one of these squares starts drawing. Now, it's a bit hard to tell that they're happening on the note hits at the moment, but once we speed up the animation of the square, you'll be able to see it more obviously. So let's just do that now. Rather than those slow animations, let's speed that right up. So, here we go. So now, I'm just going to clear the canvas back to black again so you can see them being drawn. So you'll see they're animating a lot quicker now. In fact, we might even speed that up a little more. So let's just make that even faster. Clear the canvas again. Okay, now let's speed up our notes, our chords, just so we can see that moving a little quicker. Let's change this to 10 and 5. Could speed it up even more. Let's go to half that again. And it's probably a little over the top, but let's just go completely crazy. Okay, so now every 1,000 samples we're playing a chord and starting the animation of a new square. Let's just clear the canvas. You see those things are being drawn pretty quickly now. We can easily, for example, change those squares to circles. So let's, rather than creating a square, let's create a circle. Now we've got circles being drawn. We could change the size. We could choose random sizes, for example, so between 5 and 10. Actually make it even bigger than that, 5 and 50. So now we've got little circles and big circles being drawn. Let's just set that back to 10 though. Change it back to square. And slow it down a little. Okay, hopefully you get an idea about what's happening there. I'm just going to change this to circle again. And back to square. Okay, you can find a lot more information. This has been obviously a very brief little introduction. You can find a lot more information on all of this stuff in the tutorial section on the Impromptu website. If you don't know any Lisp or Scheme, there's also links to online Scheme tutorials from the Impromptu tutorials page. And you can also, if you're interested in having a browse through the functions that are available in Impromptu, you can actually choose help from the Impromptu help menu. I'll just drag this over here. And you can just click on the function index. That'll basically give you a list of all the functions in Impromptu. You can click on any of these and it'll provide you with more information about what the function does. So MIDI out, for example. So here's some information about MIDI out, some example code. Okay, so that's probably enough to be going on with, and I'll see you again soon. Bye.